Welcome to Interstellar Archives. Tonight, we will be taking you through 101 facts about planets that are sure to put you through a good night's rest with relaxation and transcendence. So lay back, close your eyes, and enjoy the video. Planets are not just wanderers in the sky, but worlds with unique stories written in stone, ice, and gas. Unlike stars, they do not shine with their own light, but reflect the brilliance of suns around which they orbit. Each one is a chapter in the grand narrative of the universe, shaping the environments that cradle moons, rings, storms, and perhaps even life. The 8 planets of our solar system form a family, but they are not alike. The rocky inner worlds Mercury, Venus, Earth, and Mars contrast sharply with the gas giants Jupiter and Saturn, and the ice giants Uranus and Neptune. Their differences reveal the diversity possible, even within one system. A miniature model of the galaxy's creativity, Mercury, the smallest planet, is scarred by craters and baked by extreme temperatures. Swinging from scorching heat to freezing cold, with virtually no atmosphere, it is a silent, airless world, its surface unchanged for billions of years. It reminds us of the raw, unprotected face of planetary beginnings. Venus, cloaked in thick clouds of sulfuric acid, is hotter than any other planet in our solar system. Its surface roils beneath a greenhouse atmosphere that traps heat so effectively it could melt lead. Though called Earth's twin, it is more a warning, a vision of what happens when a planet's climate spirals beyond control. Earth, our home, is unique not because it is large or bright, but because it nurtures life. Water flows across its surface, air shields us, and ecosystems flourish in harmony and chaos. From space, Earth shines as a blue jewel, fragile yet resilient, a rare oasis in the desert of space. Mars is a frozen desert, its rusty surface etched with valleys, volcanoes, and canyons larger than anything on Earth. Once it may have flowed with rivers and seas, hinting at a warmer past. Today, robotic explorers search its dust for signs of ancient life, making Mars a frontier of discovery. Jupiter, the largest planet, is a swirling giant of hydrogen and helium. Its great red spot, a storm larger than Earth, has raged for centuries. Surrounded by dozens of moons, including volcanic Io and ocean-harboring Europa, Jupiter is a miniature solar system within itself. Saturn is famed for its magnificent rings, vast arcs of ice and rock that shimmer like cosmic jewelry. Yet Saturn is more than beauty. It is a gas giant of storms and winds, with moons like Titan and Enceladus that may harbor the chemistry of life beneath icy shells. Uranus tilts on its side, rolling around the sun like a cosmic barrel. This unique tilt gives it extreme seasons that last for decades. Its atmosphere, tinged blue with methane, hides mysteries beneath, while its faint rings and moons orbit in elegant, tilted harmony. Neptune, the farthest planet, is a world of deep blue storms and supersonic winds. Though distant, it radiates more heat than it receives from the sun, driving chaotic weather in its icy skies. Its largest moon, Triton, may be a captured world, whispering of cosmic theft. Exoplanets beyond our solar system expand our view of what is possible. Thousands have been discovered, from giant hot Jupiters hugging close to their stars to rocky super-Earths orbiting in habitable zones. Each discovery shows us that our solar system is not unique but part of a vast galactic menagerie. Some planets orbit to stars, like those imagined in science fiction. These circumbinary planets experience double sunrises and sunsets, dancing to the pull of twin suns. Their skies would be both beautiful and alien, testaments to the flexibility of planetary formation. Not all planets orbit. Stars some drift alone through the galaxy as rogue planets. Cast out from their systems, they wander in darkness, lit only by the faint glow of their internal heat. They are cosmic orphans, reminders that not all worlds find stable homes. Gas giants like Jupiter may shield inner planets from comets and asteroids, acting as cosmic guardians, yet they can also fling dangerous objects inward, altering planetary histories. The presence of giants may determine whether smaller worlds can thrive in safety. Moons, though not planets, transform planetary systems into rich ecosystems. Titan's methane lakes, Europa's hidden oceans, and Triton's geysers suggest that life's potential extends beyond planets themselves. Moons may be the hidden gems of planetary science. Rings are not unique to Saturn. All the giant planets have them, though fainter and less dramatic. These rings are sculpted by gravity, collisions, and icy debris. They show that even small particles, when organized by forces, can create breathtaking beauty. Planetary atmospheres determine their fate. Thin atmospheres leave surfaces barren and scarred, while thick ones can trap heat or shield life. Studying atmospheres across planets reveals the delicate balance needed for habitability and survival. Planets form from disks of gas and dust around young stars. Within these disks, grains collide, clump, and grow, eventually becoming planets. This process, spanning millions of years, is a cosmic alchemy that turns stardust into worlds. Some exoplanets are so close to their stars that their surfaces may be molten, seas of lava reflecting starlight. Others are water worlds, covered entirely in oceans, with no land. The diversity is staggering, showing us that the universe imagines worlds stranger than fiction. Studying planets is more than cataloging their traits. It is searching for ourselves among the stars. Each planet we find, whether barren or vibrant, teaches us more about Earth, life, and the possibilities that stretch into the cosmos. They remind us that we are not alone in imagining other worlds, for the universe itself has crafted countless examples. Some planets are tidally locked, meaning the same side always faces their star, just as the moon shows only one face to Earth. On such worlds, one hemisphere bakes under eternal daylight, while the other freezes in perpetual night. The thin twilight band between them might be the only region where life could survive. Jupiter's magnetic field is the strongest of all planets in our solar system. Stretching millions of kilometers into space, it captures charged particles and creates radiation belts, so intense they would fry spacecraft. This immense magnetosphere acts like a giant shield, but also a danger zone. Venus spins backwards compared to most planets, a rotation known as retrograde. This means its sun rises in the west and sets in the east, though its days are longer than its years. The slow, reversed spin remains a mystery, perhaps caused by ancient collisions. Mars has the largest volcano in the solar system, Olympus Mons, which towers nearly 3 times higher than Mount Everest. Though extinct, its sheer size reveals that Mars once had enough heat and activity to sustain massive eruptions. It stands as a frozen monument to planetary fire. Uranus and Neptune are known as ice giants because they contain large amounts of water, ammonia, and methane beneath their atmospheres. These substances, compressed into exotic ices, make them different from gas giants like Jupiter and Saturn. They represent a unique class of worlds. Planetary migration is a process where planets shift from their original orbits due to gravitational interactions. This explains why many exoplanets, like hot Jupiters, orbit dangerously close to their stars. Planets are not fixed, but wanderers, even after formation. Saturn's moon, Titan, is larger than the planet Mercury and has a thick atmosphere rich in nitrogen. Rivers and lakes of liquid methane carve its surface, creating an alien hydrological cycle. If life exists there, it would be radically different from anything we know. Neptune's moon Triton has geysers that erupt nitrogen gas into space. Its retrograde orbit suggests it was captured from the Kuiper Belt, making it a stolen world. Its icy surface hides mysteries that hint at subsurface oceans beneath its crust. Mercury's orbit is so close to the Sun that it experiences relativistic effects predicted by Einstein's general relativity. Its orbit precesses in a way Newtonian physics could not fully explain, making it a natural laboratory for testing cosmic laws. Some exoplanets orbit so close to their stars that they complete a year in mere hours. These ultra-short period planets are blasted by intense radiation, their surfaces likely melted or stripped away. They are extreme examples of how varied planetary orbits can be. Gas giants often host dozens of moons, many of which are fascinating worlds in their own right. Some moons may even outnumber habitable planets in the galaxy, making them prime targets in the search for extraterrestrial life. Moons extend planetary diversity exponentially. The Kuiper Belt beyond Neptune contains countless icy bodies, including dwarf planets like Pluto, Haumea, and Make. These distant objects are remnants from the solar system's birth, preserved in the deep freeze of space. They are frozen archives of history. Mars once had a thicker atmosphere that allowed liquid water to flow across its surface. Over time, solar winds stripped it away, leaving behind a cold, barren desert. The loss of air transformed a potentially habitable world into a dry relic. Jupiter's moon, Europa, has an icy shell that hides a vast ocean beneath. Tidal forces from Jupiter keep it warm, preventing it from freezing solid. Scientists believe this ocean could harbor life, making Europa one of the most promising places beyond Earth to search for biology. Some exoplanets are super-Earths, larger than our planet, but smaller than Neptune. They may be rocky worlds with thick atmospheres, potentially offering habitable conditions. Since our solar system lacks one, they show us forms of planets Earth never knew. Planets are classified not only by their size, but also by their composition. Rocky, terrestrial worlds differ sharply from gas giants, and ice giants occupy a middle ground. Understanding these categories helps astronomers make sense of the variety discovered beyond our solar system. Saturn's rings are young in cosmic terms, perhaps only 100 million years old. They may have formed from a shattered moon or captured comet, meaning we live in a special time to witness their splendor. Someday, they may dissipate entirely. The Earth's magnetic field shields us from solar winds and cosmic rays, maintaining conditions for life. Without it, our atmosphere might be stripped away like Mars's. Planetary magnetism is one of the hidden guardians of habitability. Some planets in other systems orbit dead stars that emit beams of radiation. These pulsar planets are bathed in deadly radiation, yet their discovery shows how resilient planet formation can be. Even in hostile environments, the search for planets involves methods like the transit method, where astronomers detect dips in starlight as planets pass in front of their stars, and radial velocity, where planets tug stars back and forth. These techniques have revealed thousands of hidden worlds, proving that planets are everywhere. Mars has a canyon so vast it dwarfs the Grand Canyon. Valles Marineris stretches over 4,000 kilometers, as wide as the continental United States. Its formation may be linked to tectonic stresses or ancient flowing water, offering a glimpse into the geological power that shaped the red planet. Earth's oceans play a key role in regulating climate, absorbing carbon dioxide and distributing heat. No other known planet has vast liquid oceans on its surface, making Earth's blue expanses one of its most defining and life-giving features. Jupiter's immense gravity acts like a slingshot, flinging comets and asteroids into new paths. Space probes like Voyager and New Horizons have used this gravitational assist to gain speed, showing how planets can be stepping stones for exploration. Neptune's winds are the fastest in the solar system, reaching 2,000 kilometers per hour. Despite being far from the Sun, the planet's internal heat drives these fierce storms, creating a dynamic and violent atmosphere. Mercury's days are longer than its years. It takes 88 Earth days to orbit the Sun, but 176 Earth days to rotate fully. This strange resonance of orbit and spin creates extreme cycles of heat and cold across its barren surface. The dwarf planet, Pluto, once the 9th planet, remains a world of fascination. New Horizons revealed mountains of water ice, glaciers of nitrogen, and a heart-shaped plain. Though small, Pluto defied expectations, proving distant worlds are anything but simple. Venus's clouds reflect so much sunlight that it appears dazzlingly bright in the night sky. Called the morning star or evening star, it has inspired myths for millennia, even as its true surface remained hidden beneath its veil until the space age. Exoplanets known as hot Jupiters orbit incredibly close to their stars, often in just a few days. Their atmospheres swell under intense radiation, creating puffed-up giants that defy what we thought possible. Their existence challenged old theories of planet formation. Uranus glows faintly with heat, but much less than expected. Unlike Neptune, it radiates little internal energy, a puzzle that suggests a violent past collision may have disrupted its core and changed its evolution forever. Earth's moon stabilizes the planet's tilt, preventing extreme climate swings. Without the moon, Earth's axis might wobble wildly, leading to chaotic seasons. This quiet partnership shows how moons can profoundly shape the destiny of planets. Saturn's density is so low, it would float in water if a bathtub large enough existed. Composed mostly of hydrogen and helium, its lightness compared to its size makes it a giant ball of gas with an elegant ringed crown. Mars has dust storms that can engulf the entire planet for weeks. These storms, driven by sunlight heating its thin atmosphere, create a reddish haze that blocks out the sun, plunging the planet into a global twilight. Some exoplanets orbit stars so dim they receive little light, yet they may generate heat from tidal forces. These tidal interactions knead their interiors, creating warmth even in frigid systems. Such energy could sustain oceans and potentially life. The asteroid belt between Mars and Jupiter contains dwarf planet Ceres, the largest object there. Ceres shows signs of salty water beneath its surface, with mysterious bright spots that may be evidence of briny deposits. Even small worlds hold big surprises. Earth is the only known planet with plate tectonics, a process that recycles the crust, builds mountains, and regulates climate through the carbon cycle. This geological dynamism may be key to sustaining life over billions of years. Jupiter's moon. Io is the most volcanically active body in the solar system. Tidal forces from Jupiter and other moons tear at its interior, fueling eruptions that cover its surface with sulfur and lava. Io is a world of fire in orbit around a world of gas. Exoplanets have revealed atmospheres containing water vapor, methane, and even exotic clouds made of metals and minerals. Some skies may rain molten rock or glass, showing that planetary weather can be stranger than imagination. The Kuiper Belt and the scattered disk are reservoirs of icy bodies beyond Neptune. These regions feed comets into the inner solar system, acting as a bridge between planets and the interstellar medium. They are the solar system's outer frontier. Mars's polar caps are made of both water ice and frozen carbon dioxide. They expand and shrink with the seasons, breathing in and out with the rhythm of Martian years. These icy layers record climate cycles over millions of years. Planets and the habitable zones of stars are often called Goldilocks worlds. Not too hot, not too cold. They might allow liquid water to exist, but habitability depends on more than distance. It requires atmosphere, chemistry, and stability, a delicate interplay of cosmic conditions. Saturn's moon Enceladus spews icy plumes into space from cracks in its surface. These geysers contain water vapor, organic molecules, and salts, hinting at a hidden ocean below. Enceladus may be one of the most promising places in the solar system to search for life. Mercury's surface is marked by giant scarps, cliffs formed as the planet cooled and contracted. These scarps stretch for hundreds of kilometers, evidence that the small world shrank as its interior solidified. Its entire face is wrinkled from the cooling of time. Jupiter's Great Red Spot is a storm larger than Earth, raging for centuries. Though shrinking in recent decades, it remains a monument to the planet's turbulent atmosphere. The storm's persistence challenges our understanding of planetary weather. Venus rotates so slowly that its atmosphere actually moves faster than the surface. Winds circle the planet in just for Earth days, whipping the clouds around in a phenomenon called The skies of Venus are in constant restless motion. Earth's magnetic field interacts with the solar wind to create auroras, shimmering lights near the poles. These displays are not just beautiful, but evidence of invisible shields protecting us from cosmic radiation. A planetary dance of particles and fields. Mars may still have subsurface reservoirs of briny water. Radar data suggests pockets of liquid beneath its polar ice, warmed by salts that lower the freezing point. If confirmed, these hidden lakes could harbor microbial life. Exoplanets in red dwarf systems face unique challenges. Their habitable zones are close to the star, exposing them to flares and radiation. Yet red dwarfs live trillions of years, offering stability unmatched by other stars. Life could adapt in unexpected ways. Neptune's moon Triton is geologically active, with geysers of nitrogen erupting from its icy crust. Its surface is young and varied, suggesting ongoing renewal. Captured from the Kuiper Belt, Triton is both a moon and a visitor from the solar system's frontier. Planetary atmospheres can escape into space over time. Lighter gases like hydrogen leak first, while heavier ones linger. This gradual loss has shaped worlds from Mercury to Mars, leaving them thinner, colder, and less able to support surface water. Jupiter radiates more heat than it receives from the Sun. Its massive interior still contracts under gravity, releasing energy. This heat drives storms and turbulence, making Jupiter a world fueled as much by its own fire as by sunlight. Earth's climate is stabilized by the carbon cycle, which regulates greenhouse gases. Volcanic eruptions, weathering of rocks, and biological processes work in balance. Planets without such cycles may fall into runaway ice ages or greenhouse states. Like Mars and Venus, Uranus's faint rings are composed of dark material, likely carbon-rich dust. Unlike Saturn's bright icy rings, they are dim and subtle. Discovered only in 1977 when Uranus passed in front of a star. Even faint rings reveal the hidden dynamics of planetary systems. Some planets may be covered entirely in water. These ocean worlds could have depths reaching hundreds of kilometers, far beyond Earth's seas. Beneath their crushing depths, exotic forms of life might thrive, making water worlds prime targets for exploration. Mars experiences seasons like Earth because of its axial tilt. However, with its thinner atmosphere, seasonal changes are harsher. Winters bring carbon dioxide snow, and summers trigger massive dust storms that sweep across the globe. Exoplanet hunters have found planets larger than Jupiter but less dense than Cork. These puffy giants are inflated by heat and radiation from their stars, making them enormous yet insubstantial, like celestial balloons. The concept of planetary protection guides missions to other worlds. Spacecraft must be sterilized to prevent contaminating planets like Mars or Europa with Earth microbes. This ensures we don't mistake our own contamination for alien life. Venus once may have had oceans of liquid water. Models suggest a temperate past before a runaway greenhouse effect boiled them away. Venus shows that even Earth-like planets can become hellscapes under the wrong conditions. Planets form gaps and waves in their protoplanetary disks, sculpting the material around them. Observing these disks in young star systems reveals the fingerprints of planets still in formation, offering glimpses into the birthplaces of future worlds. Neptune's magnetic field is tilted and offset from its center, creating chaotic interactions with its atmosphere. This lopsided magnetism is unlike Earth's aligned field, showing that planetary dynamos can take surprising forms. Studying planets not only reveals their mysteries, but reflects back on us. Each discovery about atmospheres, geology, and orbits teaches us what makes Earth rare or common. Planets are mirrors in the cosmic hall, each showing a different face of possibility. Mars has towering volcanoes, with Olympus Mons as the largest in the solar system, standing 3 times higher than Everest and sprawling across an area the size of France. It is a monument to planetary fire, frozen in time when Mars's interior cooled. Saturn's rings, though wide and brilliant, are surprisingly thin, only about 10 meters thick in many places. If scaled to the size of a sheet of paper, their diameter would span a city, but their depth would be thinner than a strand of hair. Mercury's poles harbor ice in craters where sunlight never reaches. Despite its scorching dayside temperatures, these shadowed pockets preserve frozen water, showing that even the hottest planets can hide cold secrets. Venus's surface is shaped by vast volcanic plains and mysterious structures called coronae. These circular features suggest rising plumes of magma, hinting that Venus may still be geologically active beneath its suffocating skies. Jupiter's moon Europa has a smooth, icy surface etched with cracks. Beneath lies a salty ocean kept warm by tidal heating. With more water than all of Earth's oceans combined, Europa is one of the best places to search for extraterrestrial life. Exoplanets, known as super-Earths, blur the line between terrestrial and gas worlds. Some may be rocky like Earth, but larger, with thicker atmospheres. Others could be mini-Neptunes with deep oceans, expanding the catalogue of possible planetary types. The Sun's gravity holds planets in orbit, but subtle interactions between them create resonances and migrations. These gravitational dances shaped the solar system's architecture, moving giants like Jupiter and Neptune and scattering smaller bodies outward. Saturn's moon Titan has lakes and rivers, but not of water. They are filled with liquid methane and ethane. Its thick atmosphere and hydrocarbon cycle make it a world eerily Earth-like. Though sculpted from alien chemistry, Mars's thin air allows cosmic radiation to reach the surface freely. Unlike Earth, with its protective magnetic field, Mars offers little shelter. This harsh radiation makes colonization difficult, but also preserves chemical clues of its ancient past. Some planets are rogue worlds, drifting through interstellar space without stars. Formed in systems and then ejected, they wander the galaxy in darkness. Though starless, some may keep internal heat, carrying hidden oceans across the void. Uranus and Neptune are called ice giants because they contain large amounts of water, methane, and ammonia in exotic forms. Pressures within may compress carbon into diamonds, raining glittering storms deep in their atmospheres. The diversity of exoplanets has revealed lava worlds so hot their surfaces glow, tidally locked planets with eternal day and night, and planets with orbital periods shorter than a single Earth day. Reality has outpaced imagination. Earth's biosphere has shaped the atmosphere itself, Oxygen was once absent, but photosynthetic life transformed it, creating conditions for complex organisms. Planets elsewhere may bear similar signatures of life written in their air. Mars has valleys that suggest ancient rivers once carved its surface. Deltas and lakebeds hold layered sediments, recording a wetter, more hospitable past. Mars's lost water fuels the search for traces of long-dead microbes. Jupiter's immense magnetosphere is the largest structure in the solar system, extending millions of kilometers. It captures charged particles and powers intense radiation belts, a deadly halo that spacecraft must carefully navigate. Venus rotates backwards compared to most planets. A day on Venus is longer than its year, and the sun rises in the west and sets in the east. This strange motion may be the scar of a colossal ancient collision. The Kuiper Belt's icy bodies include Arakoth, a contact binary shaped like a snowman. Studied by New Horizons, it preserves the pristine materials of the early solar system. A time capsule from the dawn of planets. Earth is unique in supporting liquid water across its surface, but water itself is common in the cosmos. From icy comets to hidden oceans on moons, it is a universal thread tying planets and worlds together. The study of planets is also the study of time. They hold records of violent beginnings, evolving climates, and hidden interiors. Each one is a chapter in the greater cosmic story, teaching us about origins, fates, and possibilities. Planets remind us that we are part of a vast continuum, from Mercury's barren craters to gas giants, storms, and ocean moons' mysteries. Every world adds to the symphony of creation. Earth is but one note, rare and fragile, in an endless cosmic chorus, and so the journey ends, not with finality, but with a reminder. Planets are storytellers. They carry within them the memory of stars, the promise of oceans, and the silence of the void. To explore them is to seek ourselves among the infinite. Gas giants like Jupiter and Saturn don't have solid surfaces. Instead, their atmospheres grow denser and denser the deeper you go, until gases become fluids under crushing pressure. If you tried to land there, you'd sink endlessly into storms until heat and density destroyed your vessel. Venus's thick atmosphere creates crushing surface pressure 90 times stronger than Earth's. Walking on Venus would feel like being nearly a kilometer underwater. The oppressive weight, combined with scalding heat, makes the surface one of the most hostile environments imaginable. Planets migrate during formation. Early in the solar system, Jupiter may have moved inward and then outward again, scattering asteroids and shaping Mars's small size. This planetary wandering is common in other systems too, proving that orbits are never set in stone. Saturn's hexagon is a jet stream at its north pole, a perfect six-sided storm stretching thousands of kilometers. No other planet has such a geometric feature in its atmosphere. Its persistence for decades makes it one of the most bizarre structures in the solar system. Mars once had a magnetic field, but it faded billions of years ago. Without protection, the solar wind stripped much of its atmosphere away, leaving it thin and cold. This ancient loss turned Mars from a once blue planet into today's dusty desert world. Jupiter's moon, Ganymede, is larger than Mercury and has its own magnetic field, the only moon known to have one. Beneath its icy shell likely lies an ocean of salty water, making it both massive and mysterious, a planet-like moon orbiting a giant. Some exoplanets orbit two stars at once, like the fictional Tatooine from Star Wars. These circumbinary planets trace graceful paths, rising under twin suns. Their climates and skies would be unlike anything on Earth, worlds caught in double dawns and double dusks. The Kuiper Belt extends beyond Neptune, a vast reservoir of icy worlds. Some, like dwarf planet Haumea, are strangely elongated and spin rapidly, shaped by collisions. This distant frontier reminds us the solar system's architecture stretches far past what the naked eye sees. Mars has a canyon system so immense it dwarfs the Grand Canyon. Valles Marineris is over 4,000 kilometers long, deep enough to swallow Mount Everest. It hints at tectonic shifts or ancient water erosion, leaving behind scars of planetary upheaval. Earth's atmosphere contains just the right balance of gases: oxygen for life, nitrogen for stability, carbon dioxide for warmth. This delicate mix may be rare in the cosmos, the product of billions of years of geological and biological interaction. Exoplanet surveys reveal lava worlds, scorched by their stars until surfaces melt. On such planets, seas of molten rock bubble beneath skies of vaporized minerals, Their dayside temperatures rival stars, while their nightsides may harden into crusts. The Oort cloud, a vast icy shell far beyond Pluto, may contain trillions of comets. Though unseen, its existence explains long-period comets that dive toward the Sun. This distant realm marks the solar system's true edge, blending into interstellar space. Jupiter is a protector as much as a giant. Its immense gravity deflects or captures comets and asteroids that might otherwise strike Earth. Without Jupiter, impacts on Earth could have been far more frequent, perhaps too destructive for life to flourish. Saturn's moon Mimas looks like the Death Star from fiction, with a giant crater named Herschel dominating its face. The impact that created it nearly shattered the moon, leaving behind one of the most striking celestial resemblances in the solar system. Venus's clouds contain sulfuric acid droplets. If you tried to fly through them, the acid would corrode metals and glass. Its skies may glow faintly at night from lightning and chemical reactions, a toxic cauldron swirling endlessly. Mars has moons that may not last. Phobos, the larger, orbits so close it is slowly spiraling inward. In 30 to 50 million years, tidal forces may tear it apart, creating a faint ring round Mars before its debris rains down. Earth's oceans hide mountains taller than Everest and trenches deeper than the Grand Canyon. These undersea landscapes remind us that even on our own planet, vast alien worlds remain unexplored, as mysterious as the surfaces of distant planets. Planets like Jupiter radiate strong radio emissions from their magnetic fields. If you had sensitive ears in space, you could hear their auroras as eerie whistles and crackles. These radio voices are the hidden music of planets. Some exoplanets orbit so close to their stars that they are torn apart by stellar radiation. They trail streams of vaporized rock like comets, slowly evaporating into space. These doomed planets reveal the violence of extreme orbits. Titan's thick atmosphere is nitrogen-rich, like Earth's, but frigid and alien. Methane rain falls into rivers, feeding lakes and seas. Standing on Titan, you'd see an orange sky, a landscape shaped by a cycle both familiar and strange. Mars's soil contains perchlorates, reactive chemicals that complicate the search for life. While they make surface life difficult, they could provide energy for microbes underground. Adding a paradoxical twist to astrobiology, Earth's tilt is stabilized by its moon, but in other systems, planets without large moons may wobble wildly. Their climates could swing violently, challenging life to adapt or perish. Our moon's quiet presence has been essential to Earth's stability. Saturn's rings may be temporary, perhaps only 100 million years old. They could vanish within another 100 million as icy material spirals into the planet. We may be living in a special moment when Saturn wears its crown. Exoplanet surveys suggest planets are more common than stars. Nearly every star may host at least one world, and many harbor entire systems. Planets are not rare jewels, but the natural byproducts of starbirth, scattered everywhere. Jupiter's storms include not only the Great Red Spot, but countless ovals and tempests. Its bands of clouds are separated by jet streams, moving in opposite directions. A colossal atmosphere in perpetual motion. Neptune radiates more heat than it receives from the Sun. Deep inside, leftover formation energy and possible diamond rain fuel its storms. This hidden furnace makes it more active than its distant, frigid location should allow Earth's continents drift because of plate tectonics, unique among known planets. This process cycles carbon, builds mountains, and continually reshapes the surface. Without it, Earth's climate might have long ago collapsed into instability. Mercury is shrinking as its interior cools, causing surface cliffs to form. Even today, its crust may still be contracting slightly, showing that planets continue evolving over billions of years. Some exoplanets are tidally locked, with one side in perpetual daylight and the other in endless night. Between lies a twilight band that could be the most habitable zone, a narrow strip where day and night meet in eternal balance. Europa's icy surface constantly shifts. Cracks and ridges suggest the crust floats atop a liquid ocean, moving like Earth's sea ice. If life exists there, it might be stirred by this restless, shifting lid of ice. Mars's atmosphere is only about 1% the density of Earth's, yet dust devils tower kilometers high. These swirling columns of dust, powered by sunlight, scoured the land and leave tracks across the surface. Exoplanet hunters discovered mini-Neptunes, worlds larger than Earth but smaller than Neptune. Their thick atmospheres make them inhospitable. yet their abundance suggests they may be the most common planetary type in the galaxy. Earth's Van Allen belts trap charged particles in magnetic loops. Without them, life would be bombarded with radiation. Planets without magnetic shields may be stripped bare, showing how invisible barriers define a world's survival. Pluto, though small, has a nitrogen atmosphere that collapses and reforms as it orbits. At its farthest, gases freeze to the surface. Closer to the Sun, they sublimate back into air. Even tiny planets breathe in cosmic rhythm. Saturn's moon, Iapetus, has a striking two-tone appearance, one side bright, the other dark. This contrast may result from dust falling from outer moons and being baked by sunlight, painting Iapetus with a cosmic yin-yang. Earth's biosphere has endured asteroid strikes, ice ages, and extinctions. This resilience shows how planets evolve with life, not apart from it. Worlds may transform repeatedly, yet remain cradles for new beginnings. Jupiter's atmosphere has lightning storms many times stronger than Earth's. These bolts illuminate the cloud tops, lighting up the darkness of its endless tempests with sudden flashes of cosmic fire. Some planets form around dead stars. White dwarfs may host planets that survived stellar death, while neutron stars have been found with exotic worlds orbiting them, bathed in deadly radiation, yet stubbornly clinging to existence. Mars's seasonal carbon dioxide cycle causes its poles to breathe. In winter, carbon dioxide freezes into ice caps. In summer, it sublimates back into the atmosphere. This delicate rhythm drives winds and weather. The discovery of thousands of exoplanets has revealed systems where planets orbit closer than Mercury, and others where giants roam far beyond Neptune. The diversity of planetary systems shows that our solar system is only one of countless variations. Saturn's Enceladus ejects plumes of water that become part of the E-ring. Each geyser is a whisper from a hidden sea, a message from an ocean world beneath an icy crust. The plumes carry potential clues to habitability. Neptune's color comes from methane, which absorbs red light and reflects blue. Its rich azure hue makes it the most strikingly blue planet, a jewel gleaming in the outer solar system's darkness. Earth's climate has been stabilized for billions of years by feedback cycles. This stability is rare. Runaway heating or freezing can destroy habitability. Our planet's balance is fragile, a cosmic gift. Uranus rotates on its side, likely knocked over by a colossal impact. Its poles point almost directly at the Sun during parts of its orbit, giving it the strangest seasons in the solar system. Venus's thick clouds trap heat so efficiently that even its night side remains scorching. Its greenhouse effect is so extreme it serves as a cautionary tale of what happens when climate spirals out of control. Crust preserves ancient craters better than Earth's without plate tectonics or much erosion. Scars from billions of years ago remain visible, a record of impacts that Earth has long since erased. Jupiter's core may be a fuzzy mixture of rock and metal dissolved into hydrogen. Unlike Earth's solid center, it may be a swirling soup of exotic matter, challenging our definitions of what a core even is. Exoplanets orbiting pulsars endure constant blasts of radiation, yet some have been found, proving that planets can persist even around the most hostile stars. Survivors of stellar explosions, Earth's water may partly come from asteroids that delivered it during the planet's early years. This cosmic rain seeded the oceans, blending extraterrestrial origins with terrestrial evolution. Saturn's rings are not solid sheets, but billions of icy particles, from dust grains to house-sized chunks. Their collective motion creates the illusion of a continuous structure, a harmony of countless fragments. Pluto's heart-shaped plain, Tombaugh Regio, is made of nitrogen ice that flows like glaciers. Even in the deep freeze, Pluto is active, its surface reshaped by slow but steady motion. Planets can affect their stars. Hot Jupiters tug so strongly they cause stars to wobble, and in rare cases, planets may even strip material from stars. Worlds and suns are locked in constant dialogue, shaping each other's fates. Earth's atmosphere glows faintly at night with airglow, light produced by chemical reactions. Other planets likely have similar subtle halos, faint signs of their living skies. Exoplanets in habitable zones may have moons large enough to be habitable themselves. These exomoons could host oceans and atmospheres, doubling the chances for life in alien systems. Mercury's nights plunge into unimaginable cold. Without an atmosphere to trap heat, temperatures can drop to nearly -180 degrees Celsius. Even though daytime highs soar above 430 degrees Celsius, this violent swing between extremes makes Mercury a planet of contradictions, a world where scorching fire and frigid ice coexist within a single day. Venus's mountains tower above the thick yellow skies, shrouded in perpetual haze. Maxwell Montes, its tallest range, rises higher than Everest. To climb it would mean ascending through layers of sulfuric acid mist while standing on volcanic rock baked at 460 degrees Celsius, a surreal reminder that mountains are not only Earth's treasure, but a universal expression of planetary upheaval. Earth's atmosphere glows with a prayer, aurora, when solar winds collide with its magnetic field. Curtains of green, purple, and red light ripple across polar skies, silent yet powerful. No other known planet offers a show quite like it, though Jupiter and Saturn produce auroras invisible to human eyes, proving that even light shows are part of planetary diversity. Mars may once have had a vast northern ocean, covering a third of its surface. Ancient shorelines and sediment suggest waves once rolled across its red expanse, shaping deltas and beaches. Today, only dry valleys remain, but they whisper of a time when Mars may have had blue seas and perhaps thriving ecosystems beneath its skies. Jupiter's great red spot has raged for centuries, but recent data show it shrinking. Once wide enough to swallow 3 Earths, it has contracted to fit just over 1. Yet its winds remain ferocious, circling at hundreds of kilometers per hour. This storm is a survivor, enduring generation after generation of human observation. A cosmic hurricane whose ending may one day arrive. Saturn's rings are sculpted by Shepard, Moon's tiny satellites that tug at particles and carve sharp edges. Pan, a small moon within the ink gap, has scooped a path through the rings, creating ripples in its wake. These interactions reveal how moons and rings exist in delicate harmony, shaping each other across eons. Uranus tilts on its side, rolling around the sun like a spinning ball. Its unusual tilt likely resulted from a colossal impact long ago, one that knocked the planet onto its side and forever altered its seasons. During solstice, one pole faces the sun for decades, while the other languishes in darkness, making Uranus's years the strangest in the solar system. Neptune's winds, the fastest of any planet, howl at 2,000 kilometers per hour. These supersonic gales tear across its icy atmosphere, sculpting clouds into strange shapes. Despite its distance from the sun, Neptune is far from quiet. Its storms are proof that even the outer reaches of the solar system are alive with dynamic weather. Pluto's surface features a vast heart-shaped plain of nitrogen ice, called Tombor Regio. Glaciers creep slowly across this frozen land, reshaping it even in frigid conditions. Its flowing ice has challenged the idea that small, distant worlds are geologically dead. Pluto breathes with slow but undeniable motion, a frozen heart that still beats faintly in the dark. Exoplanets orbiting red dwarfs may be tidally locked, one side always facing the star and the other shrouded in endless night. Yet in the twilight zone between, temperatures could allow liquid water. These narrow habitable belts are worlds of perpetual sunrise, balancing between extremes, proving that life may thrive in unlikely slivers of stability. Saturn's moon Enceladus is one of the most tantalizing worlds. Beneath its icy shell lies a global ocean, venting plumes of salty water into space. These geysers carry organic molecules, hinting at conditions suitable for life. To fly through its plumes is to taste the spray of an alien sea, perhaps rich with microbial secrets. Mars's dust storms can engulf the entire planet, turning it into a global haze for weeks or months. Powered by solar heating of its thin atmosphere, these storms reduce sunlight, chill the surface, and choke the sky. They transform the red planet into a world of twilight, a reminder that weather on other planets can rival even Earth's wildest extremes. Jupiter's magnetosphere is so immense, it would appear larger than the full moon if visible from Earth. It stretches millions of kilometers into space, trapping charged particles and blasting moons like Io and Europa with radiation. This invisible shield is both protective and destructive, shaping the environments of everything within its grasp. Earth's continents drift slowly over molten rock. This motion, driven by plate tectonics, recycles crust, builds mountains, and regulates climate through the carbon cycle. No other known planet has active plate tectonics, making Earth's geology unique and perhaps crucial to maintaining life for billions of years. Venus's atmosphere is thick with carbon dioxide, creating a greenhouse effect so extreme that its surface is hotter than Mercury, despite being farther from the Sun. This runaway warming serves as a warning of climate gone unchecked, a mirror of what happens when feedback loops push a planet past its tipping point. Neptune's moon. Triton orbits in the opposite direction of Neptune's rotation, suggesting it was captured long ago. Its surface shows geysers of nitrogen erupting into space, driven by seasonal sunlight. Triton is a moon in revolt, a wandering body from the Kuiper belt, held in uneasy partnership with its giant captor. Mars's polar caps are made of water, ice and frozen carbon dioxide. Each Martian year, they grow and shrink with the seasons, breathing in and out as carbon dioxide freezes and sublimates. These cycles record climate rhythms across eons, preserving a layered history of Martian weather. Some exoplanets orbit so close to their stars they complete a year in mere hours. These ultra-short period planets are blasted with radiation, their surfaces likely molten. Yet their survival shows how gravity can hold worlds in place, even in the furnace of creation. Earth's oceans may have been seeded by comets or asteroids delivering water-rich material. If true, it suggests life's key ingredient is not limited to planets but carried throughout the cosmos. Water, the universal solvent, may be the most widespread legacy of planetary birth. The asteroid belt, though often imagined dense, is mostly empty space. Yet within it lies dwarf planet Ceres, whose bright spots reveal salty deposits. These shimmering stains may hint at underground brines, showing that even small worlds harbor planetary secrets. Jupiter's moon. Europa may be the most promising home for life beyond Earth. Its cracked, icy shell hides a deep global ocean warmed by tidal heating. Water seeps upward, freezing into strange ridges and domes. The possibility of hydrothermal vents at the ocean floor makes Europa a sibling to Earth's most life-friendly environments, where microbial colonies could thrive in eternal darkness. Saturn's hexagon at its north pole is one of the strangest planetary features in the solar system. This six-sided jet stream is locked into place by stable atmospheric waves endlessly circulating around the pole. Unlike anything seen on Earth, the hexagon is both storm and pattern, a geometric masterpiece woven into Saturn's endless clouds. On Mars, Olympus Mons rises nearly 3 times higher than Mount Everest, the largest volcano in the solar system. Its sheer size reflects Mars's lack of plate tectonics, without shifting crust to carry magma elsewhere. Eruptions built the same mountain for millions of years. The result is a colossal monument to planetary fire. Standing silent over the red plains, Venus rotates backwards compared to most planets, spinning east to west. A day on Venus lasts longer than a year, meaning the Sun rises in the west and sets in the east after 243 Earth days. This reversal of rhythm makes Venus an alien clock, a reminder that even time itself bends differently on other worlds. Mercury is shrinking. As its iron core cools, the planet contracts, forming giant cliffs called lobate scarps that snake across its surface. These wrinkles reveal a world still settling into itself, slowly collapsing as it loses heat. A fossilized record of planetary evolution written across its crust. Uranus is ringed by a system far fainter than Saturn's, composed of dark, narrow bands of icy debris. These hidden rings reflect little light, making them hard to spot, but they prove that ring systems are not unique. Even this tilted, distant world is adorned with subtle jewelry forged from shattered moons or leftover building blocks. Mars once had a magnetic field, but it faded billions of years ago. Without this shield, solar winds stripped its atmosphere, transforming a once wet planet into the arid desert we see today. Its loss of magnetism may explain why Earth teems with life, while Mars struggles to hold even a whisper of air. Neptune radiates more heat than it receives from the Sun, hinting at internal activity, whether from residual formation, energy, radioactive decay, or deep convection. This mysterious warmth powers its fierce storms and violent winds. Even at the edge of the solar system, energy still flows from planetary hearts. Gas giants don't have solid surfaces. Descending into Jupiter or Saturn would mean sinking through layers of cloud, deeper and deeper into crushing pressures. Hydrogen itself transforms into exotic metallic forms under such weight, generating magnetic fields. To stand on these planets is impossible. They are seas of atmosphere with no shore. Titan, Saturn's largest moon, has rivers and lakes, but they are filled with liquid methane and ethane instead of water. its orange skies drizzle hydrocarbon rain, creating landscapes eerily reminiscent of Earth's. Titan is a mirror world, echoing Earth's geology with alien chemistry, showing how planets and moons can reinvent familiar patterns. Mars's Valles Marineris is a canyon system so vast it dwarfs the Grand Canyon. Stretching 4,000 kilometers long and 7 kilometers deep, it scars nearly a quarter of the planet's circumference. Its origins remain debated, perhaps a tectonic crack widened by erosion, or the collapse of land over empty magma chambers. Either way, it is the solar system's great wound. Venus's thick clouds hide flashes of lightning, a phenomenon once doubted, but now confirmed. These storms crackle within its acidic haze, proving that even beneath suffocating pressure and toxic skies, the raw power of electricity still dances. Lightning on Venus is a hidden heartbeat in its perpetual gloom. Some exoplanets are hot. Jupiter's gas giants orbiting extremely close to their stars. Their atmospheres swell and sometimes evaporate under intense heat, trailing comet-like tails of gas into space. These worlds challenge theories of planet formation, suggesting migration and chaos sculpt planetary systems in ways we never imagined. Earth's moon stabilizes our planet's tilt, preventing chaotic shifts in climate. Without it, Earth's seasons might swing wildly, perhaps too violently for complex life to thrive. The moon is not just a companion but a guardian, silently shaping the stability of our biosphere through its steady pull. Mars's soil contains perchlorates, salts that lower the freezing point of water. These chemicals could allow briny flows to appear seasonally, though they are toxic to most life as we know it. Still, they highlight how chemistry shapes the habitability of worlds, creating niches where survival is just barely possible. Venus has more volcanoes than any planet, over 1,600 major ones mapped. Many appear dormant, but evidence suggests some may still rumble. Infrared studies hint at recent lava flows, raising the possibility that Venus is not geologically dead, but alive with fiery breath hidden beneath its clouds. Jupiter's moon, Io, is the most volcanically active world in the solar system. Its surface is reshaped constantly by eruptions, fountains of lava blasting into space. Tidal forces from Jupiter and neighboring moons stretch Io like taffy, heating it from within. It is a tortured, fiery sphere, forever molten under the weight of its giant master. Earth's magnetic field not only shields us from cosmic radiation, but also leaves traces in rocks. As molten lava cools, minerals align with the planet's field, recording its past directions. These frozen compasses reveal reversals in polarity, evidence that Earth's shield flips every few 100,000 years in a restless planetary heartbeat. Pluto's thin atmosphere is made mostly of nitrogen, but it behaves strangely. As Pluto drifts farther from the Sun, its air can collapse, freezing onto the surface like frost. Its atmosphere is temporary, breathing in and out with the seasons of its long, eccentric orbit, as if the planet itself inhales and exhales with time. Some planets may be rogues, wandering alone without stars, ejected during system formation or stripped by gravity. These dark worlds drift through interstellar space. Without sunlight, they may still harbor warmth from internal heat. Cloaked in eternal night, the universe could be filled with such lonely travelers, planets without a home.